My dear students, welcome you all to my YouTube channel Learning Island. Today I am again with you with the numerical solution exercise 8b video number 5. So before this there are more 4 videos, so please watch this video also. I have given the link in the descriptions. So let us start. So today we have start with the question number 11. So in the question number 11 it is given that a combination consists of 3 resistors in series. 4 similar sets are connected in parallel. If the resistance of each resistor is 2 ohm, find the resistance of the combinations. So what is that? A combination consists of 3 resistors in series. So first of all, let us draw the diagram, then it will be easy. So you see, in first criteria it has been told that there is 3 resistors are in series. So this will be like this. If it is, and the value of the resistors are 2 each, so it is 2 ohm. This is also 2 ohm. This is also 2 ohm. So there are such 4 sets. So let us draw 4 sets. Two set, three sets, 4 sets. So these 4 sets are in the second sentence. It has been mentioned that 4 similar sets are connected in parallel. So we know what is parallel connection. So if I connect these 4 sets in parallel, so this will be like this. Just a minute. This will be like this. We will join all the terms in one here, and we will connect this with this. So finally we will get the circuit like this. Okay, so now find out the resistance of the combinations. So you see these 4 sets are in parallel series. So these all are 2 ohms, 2 ohms, 2 ohms. So let us first of all find out, because in every set there are 3 resistors. So they are in series. So if I combine those, we can get a combination of connection like this. I'm doing it step by step. What is this? If this is R1, R2, R3 and R4. So here R1 will be combination of these 3. So this will be this in series. So R1 will be equal to 2 plus 2 plus 2 equal to 6 ohm. Similarly, if I take the equivalent of this as a R2, so R2 will be equal to 2 plus 2 plus 2 equal to 6. Similarly, combination of these three is a R3. So R3 will be again 6 ohm. Again this R4 will be 6 ohm. So here R1, R2, R3, R4 all are 6, 6, 6. If I draw another in place of these 4 sets, if I put another equivalent resistor, if it is R, so we can write now 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So put this value 6, 1 by 6, 1 by 6, 1 by 6. So this is very simple. So LCM will be 6, and in the upper portion 1 plus 1 plus 1. We get 4 by 6. On simplification, we are getting 2 by 3. So total equivalent resistance of the circuit will be 3 by 2. That means 1.5 ohm. So if we simplify any circuit step by step, then it is very easy to us to solve the numericals. So I hope you understand these numericals. So let us see the final answer. This is the final answer. So now we can go to the next questions. Question number 12. In the circuit shown below in figure, calculate the value of x. Here we will have to calculate the value of x. Other here there are 4 resistors in the series in the circuit. So 3 are given and 1 is not given, that is x. We'll have to find out this. So the equivalent resistance is given. Equivalent resistance R equal to 4 ohm. So here you see, you can go step by step. Here you see 4 ohm and 8 ohm are in series. So if the equivalent resistance of these two is R1, then we will get is equal to 4 plus 8, that is 12 ohm, because they are in series. So in series we add the resistance to get the equivalent resistance. Here also, if the equivalent of these two resistors is R2, then we can write x plus 5 ohm. Again R1 and R2 are in, again R1 and R2, if this is R1, this is R2, they are in parallel. So if the equivalent resistance of these two is R, so we can write 1 by R equal to 1 by R1 plus 1 by R2. So 1 by R, the value of R is given, this is 4. So we can put it here, 1 by 4 equal to, we know 1 by R1, we know the value of R1, it is 12, and 1 by R2 is x plus 5. So on simplification we can get like this. If I cut 4 3s, so it will be 1 equal to 1 by 3. Sorry, it will not get cut because it is 1 by 12. We can do like this. The 1 by 4 equal to LCM of this will be 12x plus 5. So here will be x uh, plus 5 plus 12. So this will be x plus 17 by 12 into x plus 5. Now we can cut 4, 3. So one more simplification, we get x plus 17 equal to 3x plus 15. So if I further simplify, we are getting 2x equal to 17 minus 15 will make it 2. So x equal to 1 ohm. So finally the value of x is coming 1 ohm. So hope this step-by-step calculation you find very easy. So let us get the final solutions here. Yes, the value of x is 1 ohm. So hope this is very clear to you. So you can write it down after pausing the video, the final solutions. And let us go to the next question. Question number 13. Calculate the effective resistance between the points A and B in the circuit shown. Here you see this is a very complicated circuit. Not complicated if you solve it step by step. So you see here in this 1, 2, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 resistance. So we'll have to find out the equivalent resistance. So let us simplify it like this. Here in this case, first this 1 ohm and this 1 ohm and this 1 ohm are in series. So if I combine those to find out the equivalent resistance, if it is R1, so it will be 1 plus 1 plus 1, that is 3 ohm. Again these 2 ohms and 2 ohms are in series. So if I combine this with the equivalent resistance, so if it is R2, so this will be 2 plus 2 plus 2, it will be 6 ohm. Now if I redraw the circuit, it will show uh, like this. So it will be like this. Because this is R1 which has been replaced 3 resistance, 1 ohm, 1 ohm and 1 ohm. This is 2 ohm, this is R2 and this is 1 ohm, this is 1 ohm. So here it is R1 equal to 3 ohms, R2 equal to 6 ohm. Now you see these R1 and 2 ohm and R2 resistors are in parallel. So if we combine these three and let this is R3, so as per the rules of parallel combination, equivalent resistance we can write like this: 1 by R3 equal to 1 by R1 plus 1 by 2 plus 1 by R2. So 1 by R1 is 3, 1 by 3 plus 1 by 2 plus 1 by 6. If I do the simplification, the LCM is coming 6. So it will be 2 plus 3 plus 1. So we are getting 6 by 6 equal to 1. So finally R3 is coming 1 ohm. So now we can redraw the circuit like this. So this is 1 ohm, this is 1 ohm this is 1 ohm. So finally the total equivalent resistance of these three will be, because they are in series again, so if it is R, then you can write 1 plus 1 plus 1, because they are in series, total is 3 ohm. So final resistance of this circuit between A and B will be 3 ohm. So hope this is very clear to you, because whenever you simplify it step by step basis, then it is not so tough. So let us find the final solutions here. So this is the final solutions. Hope this is very clear to you. Please pause the video and write it down. Then let us go to the next questions. Next question is question 14. A uniform wire with a resistance of 27 ohm. So what happened? Given is there is a wire of uniform resistance. Suppose this is A, B. This is wire. The resistance is 27 ohm. It has been divided in three equal parts. So if I divide it, cut it in three equal parts, it will be like this: part 1, part 2, part 3. So if I name this A, C, D, E, F and B. So here we are dividing, that means the length is getting reduced, so the resistance will also, the resistance is the proportional to the length. So if I reduce the length, remaining the cross section same, so the resistance will be also reduced in the same ratios. So here it has been divided in three portions, so 27 by 3, it will be 9. So the resistance of the every portions will be 9 ohm, 9 ohm. Now find and they are joined parallel. So if I now joined this parallel, so this will be like this. And parallel connections. Here you can show this wire with resistor symbol also, no matter. So this is like this. So now if we join this, so this is 9 ohm, this is 9 ohm, this is 9 ohm. As they are in parallel, if the equivalent resistance of these three is R, so we can write 1 by R equal to 1 by 9 plus 1 by 9 plus 1 by 9. On simplification, LCM is 9, so here it is 1 plus 1 plus 1, so 3 by 9, finally 1 by 3, so R will be 3 ohm. So if we connect these three wires after equally divided in parallel series, in parallel connection, then the equivalent resistance will be 3 ohm. So hope this is clear. So go to the final solutions. This is the final solutions. Now you can go to the question number 15. Here you see a circuit consists of 1 ohm resistor in series. So a circuit is like this. If I draw the circle, if I draw the circuit like this, step by step, 1 ohm is there in series with a parallel combinations of 6 and 3 ohm. So with this there are again two resistance which are connected in parallel. So with these two resistance, one is in series, so this will be, if it is 6 ohm, this is 3 ohm. So how can we find out the equivalent or total resistance of the circuit? So again we are going to step by step. If I find out first the equivalent resistance of these two is R1, then we are getting 1 by R1 equal to 1 by 6 plus 1 by 3 because these are connected in parallel. Or on simplification, LCM is 6, so here we are getting 1, here we are getting 2. So finally 3 by 6 is 1 by 2. So R1 is coming 2 ohm. Now if I redraw the circuit with the equivalent resistance, this will stand like this. This is 1 ohm, this is 2 ohm. So now these are in series. So if the equivalent resistance is R, so we can write R equal to 1 plus 2 because they are in series. We will add it up, 3 ohm. So finally the resistance of this circuit would be 3 ohm. So hope it is clear to you. So this is the final solution you see, and this is the diagram. So hope this is very clear. If you are really get the benefit in this, please do not forget to subscribe my channel, and please also forward this video to your friends. Thank you. Bye bye. I will get you back with you in the next video. Thank you.